Hello everyone. So now we will see RC circuits with the pulse input. Okay. So first we were applying a step input like it was 5 volt for t greater than 0 always, right? For t greater than 0, 5 volt always. But now what will happen? 5 volt, 0 volt, 5 volt, 0 volt, 5 volt, 0 volt. And now there will be two conditions. That one condition is that the time period is very greater than the time constant. What is the time constant of the circuit? RC, right? So time period is very greater than RC and time period is very less than RC. So there are these two conditions. For both of the condition we have to analyze the circuit. So first take the first condition, T very greater than RC, then we will take the second condition. Okay. So let's take the first condition, T very greater than RC. That means the time constant is very small. Okay. Time constant is small. So let's analyze the circuit. Given T is very greater than RC. That means time period is very large than the time constant. Like they may not give this condition. What they would do, they will set the value of RC such that, let's assume RC is 2 seconds. They will set the value such that like they can put R equals to 2 ohm and C equals to 1 farad. So they will put RC equals to such that, and they will put T equals to 20 seconds. Okay. So what will happen? T by 2 will be 10 seconds. So now this 5 volt input remain there for 10 seconds. T by 2 is 10 seconds. That means 5 volt input remain there for 10 seconds. So if RC is 2 seconds, so how much time it will take to stabilize? 5 to time, right? So nearly it will take 10 seconds. So in 10 seconds you will completely get the, in 10 seconds you will completely get the 5 volt. If 5 volt is there at the input, the capacitor will charge from 0 to 5. How much time it will take? Nearly 10 seconds, right? So nearly it will take 10 seconds. So 5 volt will be completely charged. Okay. So this is what we were writing. So I will just write down the value. Okay. Let this thing R equals to 2 ohm, C equals to 1 farad, and RC would be 2 second, and T equals to 20 second. So I will just put it in a box and I will just write this would be given. This would be given. Okay. This thing would be given to you. Now let's analyze the circuit for 0 to T by 2. For 0 to T by 2, what is the value of V in? That is 5 volt. So this is your circuit, right? This is R, this is C, this is your V node, and here I have 5 volt. Here I have 5 volt. So now what will happen? The capacitor will charge to 5 volt. Since T is very large, the capacitor will have enough time. The capacitor will have enough time to get charged to 5 volt. So for 0 to T by 2, what will happen? The V naught value will rise to 5 volt, right? So this is what will happen. You don't know the exact time it will take, but we can make the approximate graph. So here our target is just to make the final graph, not to analyze the circuit, not to numerically analyze the circuit actually. For numerical, to realize the circuit numerically, we will solve some problem in the next video only. So we will solve assignment, there you will solve the numerical problem as well. Okay. So here we are just understanding the concept. So from 0 to T by 2, it is charged to nearly 5 volt, right? So just take T by 2 and it is charged to 5 volt. Now what is happening? The capacitor is charged to 5 volt. Now for T by 2 to For t by 2 to t, what is happening? V input is 0, right? The input is gone. This input is gone. Input is 0. And the capacitor is already charged to 5 volt. Because here Vc at t by 2, it will be 5 volt, right? So Vc at t by 2 would be equals to Vc at t by 2 plus is 5 volt. But the input is gone. But input is gone. That means there is no input. So how will the circuit look like? One end of the resistor will be connected to the ground. One end of the resistor is connected to the ground, and the other end is connected to the capacitor. And capacitor is already charged to 5 volt. And this we are calling Vc or V0. Whatever we are calling that V0. V0. So now what will happen? This 5 volt, this capacitor will get discharged through the resistor. So the capacitor will get completely discharged. Why completely? Completely discharged because T is very large. Because T is very large. So the capacitor will get completely discharged. So it is already charged to 5 volt, then it will be discharged to 0. So from 5 to 0 it will go. Right? I hope you are able to understand the concept. It was charged to 5 volt. From 5 volt to 0 volt it is discharged. Now what will happen? For 3t by 2 to for 3t by not for 3t, sorry, for t to 3t by 2. For t to 3t by 2. For time t to 3t by 2. What will happen? First thing is that Vc at t is 0. That would be equals to Vc at t plus or V0 you can say. So now the capacitor is having 0 voltage and again Vin is 5 volt, right? So again this circuit is there, RC with capacitor having 0 voltage, right? And here we have 5 volt. Now what will happen? The capacitor will again charge. Capacitor will again charge to 5 volt. So what will be the value of Vc at 3t by 2? It will be charged to 5 volt, right? And what will happen for 3t by 2 to t? Or 3t by 2 to t. Vin is 0. Initial capacitor voltage is 5 volt. The capacitor will discharge to 0. The capacitor for 3t by 2 to t, capacitor is charged to 5 volt, input is gone. Input is gone. So what will happen? This 5 volt will be discharged through the resistor to 0 volt. So the capacitor will discharge to 0 volt. So 0 volt. And this cycle goes on, right? 0 to 5, 5 to 0, 0 to 5, 5 to 0. So this cycle goes on. Goes on. So how will the final graph look like? So I will make input, output, both of them on one graph only. Okay. So let's first make the input. So V in and V note both are there. Okay, V note with green pen. Okay, V in and V note both will be there. And this is the time. This is T by 2. This is T. This is 3T by 2. This is 2T. This is 5T by 2. This was 5 volt. So what is actually happening? It is charging from 0 to 5, then discharging to 0, discharging to 0, then again charging from 0 to 5, then again discharging to 0, then again charging and again discharging, right? Again discharging, right? And this cycle goes on, right? This cycle goes on. And what is the time constant? Time constant here is RC. Tau is RC, right? So this is the final output waveform. Okay. So now there are two more methods to analyze this circuit. Okay, two more methods are there. One would be the with the concept of low pass filter. Okay, and integrator concept. So all these concepts are there, but that is out of the scope of gate aspirant. Okay, you don't need to dive that much into network analysis only, because you have 10 more subjects to study, right? So that is out of the scope of gate aspirant, so I am not teaching that here. For placements guide, that is very necessary. Okay, placement students, like for internship and placements, companies do expect that you know that analysis. Okay, so for them I will make a separate video and add that part in the course only. Okay, so, but for gate aspirant, that is out of the scope. You will be asked to solve the question. If you know this analysis, you will be able to solve the problem. Okay, and if you are a gate aspirant and very much interested in knowing those methods, then you can go to the placement playlist. There you will find. Okay, I have also uploaded that on YouTube as well. So from YouTube also you can find that. But for that, you need to know the Fourier series concept. Then you need to know what is filters, what is the Bode plot, how do you draw the frequency response. After that, you will be able to analyze the circuit. So once I teach all these things to placements guys, then I will teach them that method. Okay, so all these things you will study in signal system and control system. So placements guys should study that method, but gate aspirant don't need to focus on that method much. Okay, so whatever the circuit that I am dealing, first I have uh, told the concept of T very greater than RC, then I will tell the concept of T very less than RC. So all these questions can be solved with some other method as well, that I will not be telling here, but in some separate video I will be telling that. Okay, so let's see the second condition, T very less than RC for the same input. Okay, so this is the condition given, T very less than RC. So let's just assume RC is some 2 seconds. Okay, RC is some 2 seconds. So how much T you would expect? T is some 0.2 second. Okay, very less. So that means, let's just assume first you apply 5 volt, but that is applied only for 0.1 second. Okay, T by 2 would be 0.1 second. So 5 volt is applied only for 0.1 second, and the time constant is 2 second. So what do you think? What will happen? Will it charge to 2 volt? No. Sorry. Will it charge to 5 volt? No. It will charge very less. Okay. We shouldn't write 0.2 second. That would be very less. Let's just write T equals to 2 second. Okay. That is T equals to RC. That would be. Let's just write T equals to 1 second. Okay. So T by 2 would be equals to 0.5 second. So what will happen? So in 0.5 second, it will not be charged to 5 volt completely, because what will happen? VCT would try to go up to 5 volt. The equation will be something like this: 5 into e to the power minus t upon tau. Now tau is your RC, but at t by 2, what will happen? E to the power minus t by 2. What is t by 2? 0.5. And what is time constant RC? That is 2. So it will gain only this much value, this much of value. So let's just calculate what is this value. So 0.5 by 2 plus minus e to the power plus minus minus 1 into 0.5 by 2 e to the power, let me solve it. So after solving it, we will get around 1.1 volt. So it wanted to charge up to 5 volt, but it is charged to only 1.1 volt only, right? Because the time given is very, very less. So are you getting my point? So this is what we are going to write. This thing would be given to you, would be given. Okay. So now see what will happen. 4 0 to t by 2. V in is 5 volt, right? And time t is less than RC. So what will, oh. Yeah, so what will happen? This is R, this is C, this is R, this is C, this is 5 volt, this is V naught. Okay, now since T is less and time constant is large, the capacitor will try to go up to, the capacitor will try to charge up to, capacitor will try to charge up to 5 volt, but will not be able to reach there, be able to reach there. Now depending on the values of T and RC, depending on the values of T and RC, let VC T by 2 is 1 volt. Okay, although we calculated here in the previous analysis that VCT is 1.1 volt, right? VCT by 2 is 1.1 volt. So let's just assume it is 1 volt. Okay, so the capacitor started to charge, but it didn't get charged to complete 5 volt. It is charged to 1 volt only. So we are making the V naught waveform. Okay, the capacitor will try to charge, but it is charged to 1 volt only. Okay, like it was trying to go here, it was trying to go like this, but it is charged to only 1 volt. So actually I can't, I have to make it something like this only. It was trying to charge, but till this point only it is charged. So it is charged to 1 volt. Okay, charged to 1 volt till T by 2. Okay, one more thing I want to write. What is IC at T equals to 0 plus? What is IC at T equals to 0 plus? Tell me. At T equals to 0 plus. 5 by R, right? 5 by R. Okay. Because initially capacitor is having 0 volt and here 5 volt is there. So 5 by R current is there. Why did I write this? You will know later on. Okay. Let's just make the waveform. So V naught is charged from 0 to 1 volt. Now what is happening? For 0 to, for T by 2 to T. For T by 2 to T. V input is gone, that is 0 volt. Now what is the voltage across the capacitor? That is 1 volt. So what is the circuit now? This is the resistance, this is the capacitor that is already having 1 volt. Now this will charge to discharge to, this will try to, this 1 volt will try to discharge to 0 volt, but since time is very less, since T is very less, capacitor will not be able to discharge to 0, will not be able to discharge to 0. Actually tell me what will be the equation of capacitor voltage? It is going like this, I should, yeah, okay, fine. So what is the what will be the voltage? 1 into e to the power minus t upon tau. So how much time it is getting? It is getting t by 2 to t time. From t by 2 to t time, that means it is getting 0.5 second, right? It is getting 0.5 second. So in 0.5 second, and what is the time constant? That is 2 second, right? Time constant is 2 second. So from 1 to it is trying to discharge to 0, but it is getting the time window of, this would be the equation, right? It is getting the time window of only 0.5 second and time constant is 2. So that's why I wrote this equation. So let's just see what will be the answer. So 0.5 by 2 plus minus e to the power. So nearly it is 0.8 volt. Okay. So it is discharging. Let's first from 0 to 1 volt it is charged. Now it will discharge from 1 to 0. Sorry, it will try to discharge from 1 to 0, but it is not getting discharged to 0. It is getting discharged to some value that is 0.8 volt. Okay. But will not be able to discharge to 0. So let's just assume Vc at t would be 0.8 volt. Okay. So let's just make the waveform. This is your V naught versus time t. At t by 2 plus it was 1 volt. Okay. At t by 2 plus it was 1 volt. It was 1 volt. Now from 1 to it is discharging to 0.8. This is t by 2 and this is t. This was 1 and it is discharged to 0.8 volt. Okay. And the time constant is RC. Now just tell me one thing. IC at t equals to t by 2 plus. What is IC at t equals to t by 2 plus? Like this I am calling IC. Let's just call this one as IC2. Okay. This is IC2. What was IC1? Let's just call this was IC1. So this is the discharging current. What is the value of discharging current? At t by 2 plus, that is 1 by R, right? So this is 1 by R. Why am I writing this? You will get to know later on. So what did we see? First it is charged from 5 to, so from 0 to it was going to 5 volt but could go to up to only 1 volt. Then from 1 to it was trying to go to 0 but could go up to only 0.8 volt. Now it is having Vc at t is 0.8 volt. Okay, this is already written here, so I don't need to write. Now what is happening? For t to 3t by 2. For t to 3t by 2. For t to 3t by 2. Your V in is again 5 volt. Now your capacitor is already having some voltage. What is that voltage? That is 0.8 volt. What is the difference in this analysis versus the previous analysis? In the previous analysis here, your VCT was 0 volt. 0 to 5, 5 to 0, 0 to 5, 5 to 0. But now you are having some initial voltage here. Now you are having some initial voltage. Okay. So what is the circuit now? This is the capacitor, this is the resistance. It is having 0.8 volt and this is 5 volt. You need to draw the V0 waveform. Okay. Now what will happen? It will try to charge, right? The capacitor will try to charge. The capacitor will try to charge but can't reach up to 5 volt. Up to 5 volt. 5 volt. Now what is the equation actually? Initially 0.8 voltage, right? And steady state it is trying to go to 5 volt, right? E to the power minus t upon tau. Initially at t equals to 0 we have 5 volt, 0.8 volt, and steady state it is trying to go up to 5 volt, but since the time is very less, what is the time? Time is t to 3t by 2, that means only 0.5 second. And what is the time constant? Time constant is 2. So it will try to go down. So how much down it will go? Sorry, 0.82 it will charge, but till what point it will charge? 0.5 by 2 plus minus e to the power into 4.2 minus 5 plus minus 1.72. Yeah, so now what will happen? The capacitor will charge from 0.8 to some voltage. Now whatever the value we get after solving, we don't care much about it. Let's just assume we got the value Vc at 3t by 2 plus. From 0.8 it is charging. Let's just assume we got to 1.5 volt. Okay. So the same thing is happening here, but the difference is that it is not getting charged up to complete value. Okay. So don't just skip the video. One twist will come. Okay. There will be one twist that I will be explaining, because I am writing the value of current, right? So tell me what will be the, let's just call this current as IC3. So IC3 at t equals to t plus. What is the value of current? 5 minus 4.8, 5 minus 0.8 by R. So 4.2 by R current. Initially when the circuit is starting, the current is 4.2 by R, right? And now it is charging from 0.8 volt to some voltage, that is 1.5. We have considered let. It will charge to some value that would be 1.5, 1.6, that we don't know. But let's just assume it is charged to 1.5 volt. Okay. So it is charged to 1.5 volt. That's where it is charged, right? This is T, this is 3 by 2. So what is happening? First it is charging, trying to charge to 5 volt but getting charged up to 1 volt. Then it is discharging, trying to discharge to 0 volt but getting discharged up to only 0.8 volt. Then again charging, trying to go up to 5 volt but again charged up to only 1.5 volt. Now what will happen? Again it will try to discharge to 0 but cannot discharge to 0. It will try to go down to 0 but will remain at some voltage only. Okay. So for 3t by 2 to t, for 3t by 2 to t, V input is gone and Vc at 3t by 2 plus is your 1.5 volt. So now what will happen? It will try to discharge. This is the capacitor, this is the resistance, this is the capacitor, this is 1.5 volt. Okay, this will discharge. Let's just call this as IC4. So tell me what is the value of IC4 at t equals to 3t by 2 plus. What is the value? That is 1.5 by R. Okay, will Vc will try to go till 0 voltage but cannot reach there, but can't reach there, right? So let's just assume Vc at t equals to t plus. What should, no, not t plus, at t only. So what should we assume? So till where I should let it discharge? Let's just assume it is discharged to 1.3 volt. Okay. How much, till how much it should discharge? We don't know the exact value. We are not considering the value as well. We are just making a rough waveform. Okay. For numerical example, we will see examples, so there you will understand. But now the understanding the concept is important. So let's just assume it is discharged to 1.1 volt. So what is happening here? From 1.52 it is discharged to 1.1 volt. This was 1.5 volt and discharged to, this was 1.5 volt, it discharged to 1.1 volt till here. This is your V naught. This was 3t by 2 and this is your 2t. From 3t by 2 to t, why I am writing t? It is 2t. From 3t by 2 to 2t. It is discharged to 1.1 volt. And this I should have written here. Now tell me, what is this? This is a discharging current, right? This is, what is happening? So what I was saying, this is a discharging current, right? Because the capacitor is discharging. So this is discharging current. What about this? This was charging current, because here the capacitor was charging. So this was charging current, right? Look, the concept may seem complex to you, but it is very important to understand. Okay, I'm not gonna teach you easy things and then tell you, look, I teach very well. A real teacher is the one who teaches tough thing in a very easy manner. Okay, first thing is that in gate industry no one teaches these concepts, and if you go to previous year questions, these kind of questions are asked, and anytime in the future they can ask these kind of questions. Okay, so my duty is to teach you everything in a comprehensive manner and by making it easier. Okay, I'm not writing so much of equations or anything that makes it complex. I'm trying to break it down to very low levels, right? So this is charging current. So tell me, what is the thing that you are noticing? So first, it is charging from 0 to 1 volt. The initial charging current was 5 by R. Then when it was charging from 0.8 to some voltage, the charging current was 4.2 by R. Now the capacitor has discharged to 1.1 volt. Now for further cycle, for for 2t to 5t by 2, what will happen? What will be the value of charging current? Tell me. It will be 5 minus 1.1 by R, right? Because here I have 5 volt and here I have 1.1 volt. So the charging current would be 3.9 by R, right? 3.9 by R, right? From 1.12 it is getting charged. So let's just assume the capacitor is charged to 1.6 volt. Let capacitor charges from, now the capacitor will charge from 1.1 to some voltage, right? 1.12 it will try to go up to 5 volt, but let's just assume the capacitor charges from 1.1 to 1.6 volt. So this was the charging current from 1.1 to 1.6 we are assuming. Okay, so now what will happen? For 5t by 2 to 3t, what will be the discharging current now at 5t by 2? Because the capacitor is having 1.6 voltage, so the discharging current would be 1.6 by R, right? This would be the discharging current. So my point is, what is actually happening in charging current? Initially it was, when it started it was 5 by R. Then what happened? It went down to what value? First it was 5 by R, then it went down to 4.2 by R. Then here it went down to 3.9 by R, right? So the charging current is getting reduced. What is happening with discharging current? What is happening with discharging current? Tell me. First it was 1 by R, because it was only charged to 1 volt. It was 1 by R. Then the capacitor was charged to 1.5 volt, so it was 1.5 by R. Now the capacitor was charged to 1.6 volt, so it is 1.6 by R. So what is happening here? Slowly the charging current is getting increased. Now tell me, in the next cycle what will be the charging current? 4 minus 1.6, that means 5 minus 1.6. What is the value? Okay, here if it is 1.5, okay, so we don't really know, like now 1.6 will also discharge, right? At this time at 3t we are having 1.6 voltage, and this is the resistance, so this 1.6 will also discharge. We don't know till what value it will discharge. Let's just assume it is discharged to 1.4, so the current would be 5 minus 1.4, that means 3.6 by R, right? So again the charging current is getting reduced. So with the continuous cycle, with the continuous cycle with the continuous cycle charging current is getting reduced, charging current is reducing and discharging current is increasing. With continuous cycle, this charging current is getting reduced and discharging current is increasing, right? So at some time charging current would be equals to discharging current. Charging current would be equals to discharging current, and that we will call steady state. So what will be that value? That value will be 2.5 by R. Are you getting my point? When your capacitor is charged to 2.5 volt, at that time when your capacitor is charged to 2.5 volt, let's just assume this is our circuit. This is RC. Okay. RC. Same input is there. Same input is there. First it is 2.5. Then it goes to 0. Then again 2.5. Then again goes to 0. Okay. From 2. So not 2.5. Sorry. 5. 5 volt. 0 volt. 5 volt. 0 volt, because this cycle keeps on coming 5 0 5 0 5 0. Now this is charged to 2.5 volt, right? So this is the charging current, this is the discharging current. When V in is 5 volt, what will be the charging current? Charging current would be 5 minus 2.5, that would be 2.5 by R. This is the charging current. And when V in is 0 volt, what will be the discharging current? That would also be 2.5 by R. That would also be discharging current, right? So this is what we call, this is the steady state. Steady state. So if they can ask you in this complete analysis, what will be the VC value at steady state? VC value at steady state, that would be 2.5 volt, not 5 volt. Okay. In an RC circuit, there is an input that is applied, that is square wave input. Okay, square wave input or pulse input 5050, but at the given time, this time period is very less than RC. In this case, if they are asking what is the steady state value of the capacitor voltage, it will not be 5 volt, it will be the average value of the input. Okay, the average value of the input is, what is the average value of this input? This input, that is 5 by 2. Okay, so the steady state value is 2.5, not 5 volt. Are you getting my point or not? I hope you have understood. Let's make the waveform now. Okay, so this will be our final waveform. What I will do, I will just copy. So this is our input. So how will the output look like? First it will try to charge, will charge up to only 1 volt. Then it will discharge, will try to discharge, but discharge up to 0.8 volt only. Then again it is charged, will try to charge, let's just assume it is charged to 1.5 volt. Okay, here it is charged to 1.5 volt. Then it will try to discharge, let's just assume it is discharged to how much voltage, I don't remember, from 1.5 to 1.1. It is discharged to 1.1 volt. Then again it will try to charge, again discharge. So that's how the cycle will go on. Okay, and at steady state, the average value here would be, at steady state, average value will be 2.5 volt. This will be 2.5 volt. Okay, this is the steady state. Are you getting my point? So this is the complete analysis of this second configuration. The configuration is the same, but the condition is different. The condition is T very less than RC. So in exam, it is not asked yet, but they can ask anytime. Okay, so for gate aspirant it is very very important. So we just need to know what is the steady state value. Okay, so let's just write it down in the conclusion. So what is the conclusion? RC circuit is given to you. Okay, RC, this input is applied. This input is a periodic signal. Okay, so if they are asking what will be the steady state value of V naught, that would be the average value of the input. Okay, and what about the current? What is the IC average at steady state? IC average at steady state. Tell me what will be the IC average at steady state? At steady state, what will happen? Charging current is 2.5 by R, discharging current is 2.5 by R. So 2.5 by R minus 2.5 by R. Are you getting my point? I have made two diagram here. If I had just made this, so what is the charging current? 2.5 by R. What is the discharging current? That is minus 2.5 by R. So plus 2.5 by R, then minus 2.5 by R, then plus 2.5 by R, then minus 2.5. What is the average value of this? That is 0 ampere. Right? So at steady state, the average capacitor current will be 0. At steady state, average capacitor current will be 0. So the capacitor can be considered as a open circuit. I will repeat the statement. At steady state, average capacitor current will be 0. Average what is there? Okay, the capacitor current is not 0. Capacitor current is 2.5 by R minus 2.5 by R. 2.5 by R minus 2.5. If you take the average of this waveform, what will be the average of this waveform? This plus this by time. So this is equal, so total average will be 0. So at steady state, total average current through the capacitor will be 0. So the capacitor can be considered as a open circuit. Okay, so this capacitor can be considered as a open circuit. So IC average will be what? It will always be 0 volt. So tell me what will be the VR average voltage? VR average at steady state. What will be VR average at steady state? If the capacitor current is 0, that means the same 0 current is flowing through the resistor R as well. So it will also be 0 volt. This will be 0 ampere. Okay, and this will be 0 volt. Are you getting my point? At steady state, there is average 0 current is flowing through the resistor, right? Because it would be VR average would be IC average into resistor R. So if this is 0, this will also be 0 volt. Okay. So at steady state, what will happen? At steady state, what you can do? You can simply replace the capacitor with the open circuit. But the logic is at steady state, the average capacitor current is 0. That's why we can replace this as a open circuit. Okay. So this capacitor can be replaced with the open circuit, and this is the input applied. So whatever the average value of the input is there, the same average value will be reflected at the output. The same value will be reflected at the output. So I just assume this question is surely going to be asked in some time in gate examination or in written test, that they will ask average, some waveform they will give, and they will ask what will be the output average voltage. So what you need to do, you just need to find the average of the input voltage. The same voltage will be appearing across the capacitor. Are you getting my point? I hope you have understood the point. Okay. So I guess I can write a question. Okay. So let me pause it and I will write a question. Okay. Okay. So this is the question given to you. CR circuit is given. Okay. You have to find the steady state value of the capacitor voltage and the resistor voltage. Okay. This. So at steady state, what will happen? IC average would be 0 ampere. right? So this is the input. The capacitor can be considered as a open circuit. This is a resistor, right? And this is your VR average. Okay, this will be your VC average, right? And this is your input voltage. So tell me, what will be the value VC average value? VC average would be, since it is open circuit, there will be no current through the resistor as well. So VC average would be simply equals to V in average at steady state. Oh, everything is happening at steady state. So VC average will be equals to V in average. What is the average value of the input? Average value of the input is 10 into t by 3. For t by 3 time it is 10, and for rest of the time it is 0. Divide by time period. In one time period you need to see, it is 10 for t by 3 time and it is 0 for 2t by 3 time, right? 0 into 2t by 3. For t by 3 time it is 10, for rest of the time it is 0. So 10 into 2 t by 3 plus 0 into 2t by 3 divided by time period. So it would be 10 by 3 volt. So this is your answer for VC average. And what is VR average? VR average is 0 volt, right? VR average would be 0 volt because the current through the average current through the resistor is 0. So VR average would be 0 volt. So here we have 0 volt, here we have 10 by 3. So 10 by 3 volt will be the final answer. Are you getting my point or not? These kind of questions they may ask, and everyone think that it will charge up to 10 volt. The capacitor will charge up to 10 volt. But in reality, the capacitor will not charge up to 10 volt. It will have a steady state value of 10 by 3 volt only. Okay. So this is the final answer. So I hope you have understood the concept that I am trying to deliver here. Okay. Let's move on to the next circuit. This is a very simple circuit. Current source is given. You need to draw the VC waveform. You need to draw the VR waveform. Okay. Just two waveform you need to draw. Okay. I haven't written here. VC and VR you need to draw. This is an easy question. You should try it on your own. What will happen? This same current IS would be flowing through the capacitor forever, right? The same current IS would be flowing through the capacitor forever. So this resistance R makes no impact in capacitor voltage. We have seen this question, right? In practice problem. When there was some current was flowing, the capacitor was getting charged. Then some other current was flowing, the capacitor was getting discharged. So the resistance has no impact, right? So let's just solve the problem. This is the current source you have. Then you have a resistor. Then you have a capacitor. Resistor and capacitor. This is your VC and this is your current source, right? IS we are calling, right? IS. So this is the current source only. I guess I can copy it here. This is the current source. The same IS current is flowing through the capacitor forever, right? IS current flows through the capacitor and resistor forever. That means what? Constant current is flowing through the capacitor. Constant current is flowing through the capacitor. So what will be VCT? VCT would be 1 by C integration is dot dt. From some time, from any time, we just don't know. Let's just assume I'm writing from 0 to time t. Okay. So first it will linearly charge. When there is no current, it will stay there. When there is another current, it will charge, then stay there, charge, stay there. Okay. So let's see by one cycle. And I have also given t is equals to RC. Okay. So for 0 to t by 2, what is the capacitor current? That is 1 by C integration is dot dt from 0 to some time t. 1 by C. What is the value of Is? That is 0, sorry, I naught from 0 to T. So it would be I naught T by C. That would be your VCT. Okay. So what is your VCT? VCT is linearly charging from 0 to some value, right? From 0 to some value it is charging. This is your VCT. Till T by 2 it will charge. From 0 to T by 2 we are. What will be this value? So what will be VC at T equals to T by 2? It would be I naught T by 2 C. What is the value of T? Given T is equals to RC. This is given. T is equals to RC is given. So I can put I naught into RC by 2C. So it would be I naught R by 2. From 0 to I naught R by 2 it will charge. Now what will happen? This is already charged to I naught R by 2. For T by 2 to T. For T by 2 to T. For T by 2 to T. What will happen? Is is 0 ampere. So input is gone. Now what is the circuit? This is a resistance R. The capacitor will hold its voltage, right? The capacitor is holding its voltage. The input is gone. There is no input. The input is gone. So there is no input. The capacitor is holding its voltage. What is the voltage the capacitor is having? That is I naught R by 2. I naught R by 2. Now, what is the current through the capacitor now? Input is gone. One end of resistor R is open-ended. It is open circuited, not connected to ground. So you wouldn't say that I naught R by and I naught R by 2 voltage will get discharged. No, the voltage will not get discharged because one end of resistor is open-ended. So it will not discharge. Since it is open-ended, there is 0 ampere current flowing through it. Right? So the current is 0 ampere. If it was grounded, then we would have said that capacitor will discharge through the resistor. But since it is open circuited, that means there is 0 ampere current. So the capacitor will neither discharge nor charge. Capacitor will neither discharge and nor charge. Right? So what will happen to VC voltage? It will remain at I naught R by 2 only. Right? From T by 2 to T, it will remain at I naught R by 2. Right? Because the capacitor is neither getting charged nor getting discharged. For T to 3T by 2, what is happening? VC at T is already I naught R. Now the current is 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 I naught ampere. Now the current is there, right? Sorry, it is not I naught R by 2, it is I naught R only. It is I naught R by 2. It is R naught R by 2. This is already I naught R by 2. Now again, this same current is flowing through the capacitor. So again the capacitor will charge. I naught current is flowing through the capacitor. So the capacitor will charge. Capacitor will charge. So how it will charge? Capacitor will charge. I can write down the equation. ICT would be initially you are having how much voltage? Not ICT, what I am doing, VCT. VCT. What will be VCT? Initially I am having I naught R by 2 voltage, then from T to 3T by 2, right? From T to 3T by 2, so I will write some time T. From T to 3T by 2, I am having 1 by C integration I dot dt. So it would be I naught R by 2 plus I naught by C T minus T. Okay. So it will be I naught R by 2. This would be the equation. Okay. Simply it will charge linearly. Okay. And if I want to know what will be the voltage at 3T by 2, VC at 3T by 2. What will be VC at 3T by 2? So it would be I naught R, I naught C, 3T by 2 minus T. It would be T by 2. T is RC. So if T is RC, so it would be I naught R. So in first cycle, it reaches from 0 to I naught R by 2. So it develops I naught R by 2 charge. So let's just make the complete waveform. So what was happening? Initially from 0 to T by 2, it is I naught R by 2. Then it is constant, right? From 0 to T by 2, it is developing 0 to T by 2, it is developing I naught R by 2 voltage, right? This is VC. Then from T by 2 to T, it is constant. Then from T to 3T by 2, it is developing again more I naught R by 2. So from I naught R by 2, it is developing till I naught R. Till this is 3T by 2, right? Then what will happen for 3T by 2 to T? It will again remain constant. Then what will happen after that? Again it will charge 3T by 2 to T. Again it will charge, and how much voltage it will develop? I naught R by 2, right? This voltage developed is I naught R by 2. Here how much voltage was developed? I naught R by 2, right? So even if there is some initial voltage, that's not a matter of concern if there is constant current. So this constant current will give the capacitor I naught R by 2 amount of voltage. So in T by 2 cycle, it is giving it I naught R by 2 amount of voltage. In the next T by 2 time, it is giving it I naught R by 2 amount of voltage. And here for this time, it is remaining at the same voltage because input is gone. Okay. So again what will happen? Again it will charge. Again it will charge. Then it will remain constant. Then again it will charge. So the cycle will keep on repeating, right? So in the exam, what they can do, they can ask you questions like, what will be the capacitor voltage after 3 cycle? So tell me, what will be the capacitor voltage after 3 cycle? So in every cycle, it is developing I naught R by 2 voltage, right? Like this will be 5T by 2 and this will be 3T. So in one cycle, it is developed I naught R by 2 voltage. In another cycle, it has developed more I naught R by 2 voltage. And then in another cycle, it has developed more I naught R by 2 voltage. Right? So in every cycle, it is developing I naught R by 2 voltage. In every cycle, capacitor is developing I naught R by 2 voltage. Right? So capacitor voltage after n cycle. Capacitor voltage after n cycles of input, that would be n I naught R by 2. right? So they can ask you what is the capacitor voltage after 10 cycles. So your answer would be 5 I naught R. Then they will give you some value of R, they will give you some value of C. So this kind of question they can ask in two marks, right? Charge constant, and linear charging is there. Okay. Now the next is VR waveform. Let's just comment on VR waveform. What do you think? What will be VR waveform? It will be the same as input. Why so? Because voltage across the resistance is always I naught R, right? This is the current. This is VR. Okay. This IS current is always flowing through the resistor, so your VR would be IS into R, right? So your VR would be IS into R. That means how will your VR waveform look like? It will be the same as the input waveform. This waveform. It will be the same as this waveform, right? What different will happen? Only the current will be replaced with the VR. So what I will do, I will just replace this IS to VR and I will just write I naught R, I naught R and I naught R. Okay, are you getting my point? The same input current multiplied with the resistor, so that would be VR voltage. Okay, and if someone asks you what is VS voltage, this is the VS voltage, this is the VS voltage. If someone asks you what is the VS voltage, that will be the addition of VR and VC. So you can just add them up, right? This waveform plus this waveform. So it will start from I naught R. It will start from I naught R because initially VR is I naught R. Then it will rise to 3 I naught R by 2. Then again it will come down to I naught R by 2. Are you getting my point? For 0 to t by 2, what will happen? For 0 to t by 2, I naught R plus this waveform, I naught R plus this waveform. So from I naught R2, it will charge to 3 I naught R by 2. For t by 2 to 3 by 2, for t by 2 to t, what will happen? This is 0 plus only this voltage, that is I naught R by 2. So from I naught R to 3 I naught R, it will charge, then it will come down to I naught R by 2, then remain there. Then what will happen? This waveform plus this waveform. Then you can draw the waveform. Okay. Are you getting my point? Shall I draw the waveform? Okay, I will draw the waveform on my own. What will be the VS waveform? How will your VS waveform look like? Let's understand it directly. So initially the resistor will be having I naught R voltage. Okay. So initially this resistor is having I naught R voltage, and the capacitor will develop more I naught R by 2 voltage. So from I naught R2, we will reach till 3 I naught R by 2. 3 I naught R by 2. Right? Then what will happen in the next cycle? Input is gone. So the voltage across the resistor is gone. Right? So voltage across the resistor is gone. So VS voltage will be only with equal to the capacitor voltage, and that is I naught R by 2. Wait. That is I naught R by 2. So it has come down to I naught R by 2. Now what will happen? Again, the capacitor is having I naught R by 2 voltage, and the resistance is having I naught R voltage when input is there. So I naught R plus I naught R by 2. That means it will start from 3 I naught R by 2. I naught R by 2 plus I naught R. So it will again start from 3 I naught R by 2, and the capacitor will again develop The capacitor will develop more I naught R by 2 voltage. So the waveform will go something like this. You have to use your brain. Okay, if you are just watching the lecture and just thinking that everything will be in my mind, so I guess I'm not a good teacher for you. You should move on to some other lectures, because there they will teach you easy things and you will think that I know everything. But in the exam, teachers gonna ask these kind of questions. Okay, and then it will be a problem. So again, from 3 I naught R by 2, it is developing more I naught R by 2 charge. So it would be 2 I naught R. Right? Now what will happen? The capacitor is having I naught R voltage and input is gone. So the resistor voltage is gone. So only I naught R voltage will be there. So it will drop down to I naught R. So it will drop down to I naught R. Okay. So these kind of waveform will go on. So it will drop down to I naught R and will remain there for next cycle. Okay, so in exam, what they can ask you these questions, that what will be your Vs voltage at t equals to 3t by 2. 3t by 2 plus, they can ask you what is the Vs voltage at 3t by 2 plus, that is V naught R. Okay, sorry, I naught R, not V naught R, I naught R. Okay, so this cycle keeps on going. Okay, so I hope you understood the concept well and good. Right? What is happening? Very easy. This question is very easy. This is not tough actually. Like capacitor current, you can see linear charging is there. Charge constant, charge constant, charge constant. In case of resistor, same as the input voltage, same as the input current, same value. That's it. Now they can ask you these questions like, what will be the Vs voltage at 5t by 2? 5t by 2 minus. So Vs voltage at 5t by 2 minus would be equals to the resistor voltage at 5 to, like they can ask you Vs at 5t2 by 2 minus. So what you will do? I naught R 5t by 2 minus I naught R plus what is the what is Vc at 5t2 by minus, that is 3 I naught by R plus 3 I naught by R. So your answer would be 5 I naught R by 2. So that would be your answer. These kind of questions they can ask in the written test. Okay, or in the gate examination. So I hope you will be able to answer every question. No matter how much tough question they ask, you will be able to answer that. Right? Every tough question you will be able to answer. Why so? Because we have understood the concept very, very deeply now. Right? So let's just see if there are some concepts left. Yeah. So this concept will be used in the further analysis, initial value theorem and final value theorem, and then we will see one more question. So that's it. Like these much concept is necessary. Like these much concept will be sufficient to answer every written test question, no matter how much tough they ask. We have seen a lot of questions, we have seen a lot of concepts. So I hope you are comfortable with transient analysis very, very deeply now. Now we will see RL circuit in 1 or 2 lecture only, because it won't take much time, because we have studied RC so deeply. RL we will be able to do it very, very quickly. The same thing that is happening in the RC, the same kind of thing will be happening in RL. Okay, so let's just see this thing. So there is this thing called initial value theorem and final value theorem. You will be studying this theorem in signal system as well, in control systems as well. Okay, so this is a very, very important theorem. So let's just first study what is initial value and what is final value. So this function is given to you, ft equals to 1 minus at ut, and they are asking write down the initial and final value of this function. So what is the initial value? Initial value means we need to find the value at t equals to 0, right? Initial value means t equals to 0 plus I can write or t equals to 0. Okay, so this is what initial value means. I hope you have already guessed it, right? This is the initial value. So f of 0 plus, just put at time t equals to 0. So 0 and u of 0 plus. The value would be, this would be 1, so 0. Okay, and what will be the final value? Final value means steady state value. Okay, final value or steady state value. or DC value also we can say sometimes. DC value, that means t equals to infinity. F of infinity, that would be 1 minus e to the power minus a into infinity u of infinity. U of infinity will always be 1, so it would be 1. Okay, so 0 and 1. But now if something is given in Laplace transform, let's just assume fs is written, not fs, capital Fs, capital Fs is written as s plus 3 upon s square plus 2s plus 1. Now they are asking what is the initial value of this function. So what you can do, you can convert this Laplace domain to time domain and then put t equals to 0, or you can apply initial value theorem. Okay, so if you know the initial value theorem, you wouldn't have to convert it from s domain to time domain. Okay, you will not have to convert it from s domain to time domain if you know this theorem. So but this theorem is applicable only when the signal is existing for t greater than 0 only, or you can say that ft should be some function f1t into ut. Are you getting my point? Ft should be 0 for t less than 0. That means this cannot happen. This cannot happen. This kind of waveform cannot be there. Only these kind of waveform can be there. These kind of waveform cannot be there. These kind of waveform cannot be there. Here it will not be applicable. Here not applicable. Here not applicable. Only here applicable. That ft should be 0 for t less than 0. Okay. And it shouldn't have any discontinuity. It shouldn't contain any impulse or discontinuity. Not of. It should be or any discontinuity. So tell me, will this theorem be applicable for this function ft equals to ut? For ut, will it be applicable? Will it be applicable for ut? No. Why so? Because at t equals to 0, we are having a discontinuity. Here we are having 0 volt, here we are having 5 volt. So what is the value at t equals to 0? Discontinuity is there, right? Discontinuity is there. So it cannot be applied for ut, right? Or it can be applied 1 by s. What do you mean by discontinuity? Discontinuity means this I am talking is differentiability actually. This is not discontinuity. Like there are two things: continuous function and differentiable function. So this is non-differentiable, but this is continuous actually. This function is continuous. Like this is not breaking down like this. This function is not breaking down. So here it will be applicable actually. Okay, for ut it will be applicable because this is not discontinuous. This is non-differentiable, because at t equals to 0 you can't differentiate it. If you differentiate it, you will get an infinite value. That means you will get an impulse. So this is non-differentiable, but the theorem is applicable for non-differentiable functions. Okay, so it is applicable for non-differentiable function, but it is not applicable for discontinuous function. So discontinuous would be the signum function. These kind of functions you will study in signal system. So these kind of function, but like it is not defined at t equals to 0. So for them you can't apply it at t equals to 0. Okay. So two conditions are there. The signal should exist only for t greater than 0. First thing is that. Okay. And the second is that it shouldn't have any impulse or discontinuity at t equals to 0. Like it wouldn't be applicable for delta t, right? Ft equals to delta t. For that it will not be applicable. Why so? Because at t equals to 0 we are having an impulse, right? Okay. So let ft equals to, let Laplace transform of ft is f of s. So what will be your initial value? This is in time domain. Okay, I should have written it like this, like limit time t tends to 0 plus f of t, or you can write f of 0 plus, you don't know the function in time domain, you only know the Laplace form. So what you will do, limit s tends to infinity s into f of s. That would be your final answer. Are you getting my point? Like you need to find the initial value of this function. What is the initial value of this function? In time domain only you can find. Put t equals to 0, that is 1, right? Like there can be two methods. Initial value f of 0 plus would be e to the power minus 0 u of 0 plus, that would be 1. So this is one method. What about the second one? What is f of s? F of s for this function is 1 upon s plus 2, right? So in time domain f of 0 plus, or I should write limit t tends to 0 plus f of t, or f of 0 plus would be equals to limit s tends to infinity s into f of s. So limit s tends to infinity, what is s into f of s? What is s into f of s? That is s upon s plus 2. So s is very large, so s upon s plus 2 can be approximated to s only. So this and this will get cancelled and the value we will get 1. Look, s upon s plus 2. Now s is tending to infinity, that means s is very large. S is very larger than 2. So I can replace s plus 2 as s only. So s and s will get cancelled and you will get 1. Right? So here you can see, here also I am getting 1 and here also I am getting 1. Okay? Let's just see example number 2. You have to find the initial value for this function. So before applying the theorem, what I am doing, what is f of s? This function can be replaced with s plus 6 whole square, right, by s plus 6. So after cancelling, I am getting s plus 6. Now convert it into time domain. What is the Laplace transform of delta t? That is 1. Laplace transform of differentiation of delta t would be s into 1, that means s. Like whenever I am differentiating in time domain, what do I get? S into x, s of x. So if this is 1, so d by dt into delta t. So differentiation of this is 1, so I will only get s into 1, right? So in time domain, what is the differentiation of impulse function? That you don't need to think. What is the practical meaning of differentiation of impulse function? That also you don't need to think. Okay. So what is the final form? That is delta dash t plus 6 delta t. So what do you see here? Impulse at t equals to 0. Initial value theorem is not applicable. Initial value theorem is not applicable, right? Did you understand? Now solve this one. Before going there, before applying the theorem, let's just break it down. It would be s plus 4, s plus 3, right, by s plus 2. I can break it down like this: s plus 2 plus 2 by s plus 2 into s plus 3. So it would be 1 plus 2 by s plus 2 into s plus 3. I am breaking it down. I can break it down like this: s plus 3 plus 2 into s plus 3 by s plus 2, right? Now s plus 3 can also be broken down into s plus 2 plus 1. Just simple mathematics I am applying, nothing else I am doing, right? So it would be equals to s plus 3 plus 2 into 1 plus 1 upon s plus 2. It would be s plus 5 plus 2 upon s plus 2. So it would be delta dash t plus 5 delta t plus 2 e to the power minus 2t ut, right? So this would be my f of t. So here what do I see? Impulse at t equals to 0 at t equals to 0. Right? Impulse at t equals to 0. Did I do the calculation right? Let me check. 2 1 plus 1 s plus 3, s plus 3 comes here, 2 s plus 3 goes there, s plus 2 plus 1, 1 upon 1 plus s plus 2, 2 upon 1 plus s plus 2, 2 comes here, 2 upon s plus 5, 2 upon s plus 2. Yeah, the calculation is correct. Okay, so impulse at t equals to 0, again initial value theorem is not applicable. Is not applicable. Okay, so what do you see here? Note, in Laplace transform function, when degree of numerator is greater than degree of denominator. Okay, this mark it. Degree of numerator is greater than degree of numerator. Degree of numerator is greater than degree of denominator. Time domain function will, for this, time domain function will always have an impulse. Always have an impulse. Here in this example, degree of numerator was higher. Degree of numerator was 2. Here it was 1. Here it was 2. Here it was 1. So degree of numerator was higher and degree of denominator is lower. So whenever there is this case, always there will be one impulse for sure. Take any example and solve it. Or you can think as well, like what you are doing. You are dividing this function by this. You are doing the division, right? 12s plus 6 or 36, whatever it is, right? Then s plus 2. So s will come there for sure, and one constant value will also come. Or if constant value doesn't come, only s will be there. So it will be the differentiation of a delta t, and that is also a discontinuity. So I should have written in the better manner that will always have an impulse or differentiation of impulse, or differentiation of impulse. Differentiation of impulse. That is a discontinuity at t equals to 0. That is a discontinuity at t equals to 0. So for applying the initial value theorem, degree of numerator, so I think I can add a page and write down that f of s is numerator upon denominator, then degree of numerator should always be less than degree of denominator. Okay, even if they are equal, the final value will not be applicable. For initial value theorem to be applicable, for initial value theorem to be applicable. Okay, so always remember this point. Many times teacher miss this point and they just teach this formula. Okay, only I have seen many of the students just knowing this formula, but they don't know this concept, that if the degree of denominator is higher, you can't apply initial value theorem. Okay, so always remember this. If the degree of numerator is higher, you can't apply initial value theorem. You have to break it down to f of t. Then you need to see that at t equals to 0, I am having a discontinuity, so I can't really tell what is the initial value theorem. So initial value theorem is not applicable. So when initial value theorem is applicable. So let's just assume f of s is given as s plus 6 upon s square plus 7s plus 12, whatever it is. You just need to find the initial value. Okay, so find limit t tends to 0 plus f of t or initial value, right? So what you will do? What will be your answer? So f of t equals to 0 plus would be limit s tends to infinity s into f of s, limit s tends to infinity s into f of s. So s square plus 6x upon s square plus 7s plus 7s square plus 12s. What you can do, you can take s square as common, or what you can think that s is tending to infinity, so s square will be very large, so this upper function can be replaced with s square only, and this s square is very large. Okay, this will be s cube. Actually already there is square, so this will be s cube upon s square 12s. So this s cube will be very large, so this will be replaced with s cube. So finally you are getting 1 upon s, and if you put s equals to infinity, it will be 0. Okay, are you getting my point? Like for the numerator part, s square plus 6s, so s square will be very larger than 6s, so it will be s square. And in the denominator part, what is happening, s cube, that will be very larger than s square and s, so it will be replaced with s cube only. So we are left with limit s tends to infinity 1 by s, that would be equals to 0. Or you can do, you can take s square common, so it would be 1 plus 6 by s, or you can take s cube common from here, so it would be 1 plus 7 by s plus 12 by s square. Now if you put infinity, this will go to 0, this will go to 0, this will go to 0, so final you will have 1 by s. Now if you put infinity, this complete function will go to 0. So this you can do. Also you can think like this, that this s square will be very large, so just replace it with s square. S cube will be very large, so just replace it with s cube, and then this will be. Or you can do this, because most of the students solve like this, by this method, but I usually solve like this, a very large, then just replace that. So your f of 0 plus is 0. Okay, so your initial value is 0. So without finding the time domain function, you can tell that initial value will be 0. The graph will start from t equals to 0. Okay, so this is initial value theorem. Now what about final value theorem? So first thing is, the signal should not be unbounded or periodic. What is unbounded? This is your ut, right? This is function ut. Is it bounded? At t equals to infinity, are you having a finite value? Like you are having a finite value, that you know that at t equals to infinity it will be 1 volt only, but it is never going, like it is not completing anywhere, right? So that means bounded function means at infinity you are having 0 voltage. This is what bounded function means. Like this is unbounded function, because it is getting increasing and increasing. You don't know the steady state value, right? Look, I shouldn't, let me rephrase my statement. Okay, wait. Yeah, so I'm really sorry for the mistake that I said that ut is an unbounded signal. It is a bounded signal. What is the definition of unbounded signal? Is that it shouldn't reach infinity value at any time. Okay, so I will just write it. What is unbounded signal? Unbounded signal. That f of t goes to infinity at any point of time. At any point of time. Point of time. What is the example? Example is f of t equals to e to the power 2t into ut. So how will the waveform look like? It will just keep on increasing, right? The waveform will be like something like this. So it just keeps on increasing. Like this, right? So it just keeps on increasing. So it is an unbounded signal. Okay, ut is not unbounded, because always it will give you 1 volt, and that's a finite value. Okay, so it is not unbounded signal. So this is what unbounded signal is called. Okay, this is your unbounded signal. Okay, Okay, so the signal should not be unbounded or periodic. Periodic signal, you know, right? Periodic, the same period it follows, periodic. So these are the condition. Okay, because in periodic signal the cycle goes on, so you can't really tell what is the final value. Okay, and the pole of Fs should lie in the left half of S plane. Now what is pole? So let's just assume your Fs is this value, 1 upon S plus 2 into 1 upon S plus 3. So just put the denominator equals to 0. Okay, like all this concept you will be studying in control system and signal systems, but here it is necessary, that's why I am telling. So what is the pole of a system? Let's just assume this is your f of s. Okay, what you will do, you will put the denominator equals to 0. If you put denominator equals to 0, what is the value of s you are getting? -2 and -3. This is S plane. One is sigma, one is j omega. So the real value is called sigma, this is real, and imaginary value will be called imaginary. Imaginary value will be shown at j omega axis. So we are getting -2, -2 will be somewhere here, and -3 will be somewhere here. So the pole of Fs should lie in the left half of S plane. Okay, so here we can apply the final value theorem. Are you getting my point? Here you can apply the final value theorem. Why so? Because the poles are getting in the left half of S plane. Now let's just assume my function was something like this. My f of s was s square plus, not s square, my function was s plus 2 into s minus 2. So where will be my poles? I should write s minus 3. So where will be my poles? One pole will be at -2, one pole will be at 3. So 3 will be somewhere here, sorry, -2 will be somewhere here, and 3 will be somewhere. That's how we show the pole, by cross sign. Okay, and 3 will be somewhere here. So one of the pole is lying in the right half of S plane. So this is what we call right hand plane, and this is left half. So actually this is shown at left hand pole, right hand pole. So this is lying in the right hand side of the S plane. So if this is there, that means you can't apply final value theorem. Okay, so strictly it should lie, can't apply final value theorem. Okay, so strictly it should lie in the right half of S plane and maximum one pole at origin. Okay, maximum one pole at origin. So where if I write 1 upon s into s plus 2 into s plus 3, so what will be my pole? -2, 3, and one pole will be at 0. So maximum one pole at 0 is allowed. If there is two poles at 0, origin means 0. If there are two poles at 0, this will not be allowed. Okay, if there are two poles at 0, this will not be allowed. Are you getting my point? Final value theorem will not be allowed if there are two poles at 0. Okay, so what is final value theorem? So instead of this, I should write limit t tends to infinity. Actually, in network analysis, what happens is that whatever the questions you will encounter, no, like, and in every question, the final value and initial value theorem will be applicable. Okay, in network analysis, whatever the question, whatever the problem you see, in every problem you will be able to apply initial value and final value theorem. So while teaching network analysis, teachers don't teach all these concepts. Why so? Because the theorem will always be applicable. So they just teach the statement. Okay, so in conclusion, you just need to remember the statement. What is the statement? Limit t tends to 0 f of t is, for initial value what did we do? S tends to infinity, but for final value we will do s tends to 0, s into f of s. Same thing we will do, s into f of s, that we did here, s into f of s, just s tends to infinity. For initial value s tends to infinity, for final value s tends to 0. Okay, you don't need to mug them up because in control system and signal system you will be studying this again, but just to see that your function should not be unbounded. It should not be unbounded. Okay, all the poles should be lying in the left half of S plane. Okay, left half of S plane, not in the right half of S plane. If there is a pole at origin, this should be only one pole at origin, not two or more than two. Okay, are you getting my point? I hope you are understanding. So let's just see some examples. This is the first example. What is the steady state value or final value? So what is f of infinity? That would be e to the power minus infinity upon u infinity. So that would be 0, right? Here you can see. And more example, and by Laplace transform, what will be f of s? It will be 1 upon s plus 2, right? What will be f of infinity? That would be limit s tends to 0 s into f of s, right? So it would be limit s tends to 0 s by s plus 2. So if you put 0, this will be 0 only. Just 1 upon s plus 2 in just multiply it with s and put s equals to 0. So if you put s equals to 0 here, you will get 0 only. Now apply the theorem in this. So before applying the theorem, just make the s plane. What will be your s plane? Sigma and j omega. Okay, this is sigma, this is j omega. Find the poles. Find the poles. Poles will be s square plus a square goes to 0. So what is the value of s? That is plus minus ja. That means one pole will be here, ja, the other pole will be, sorry, pole we make, this is j omega upward. So one pole will be here and the other pole will be here. Are you getting my point? This is j omega axis, j omega imaginary, this is imaginary axis. So one pole will be here and the other pole will be here. So the poles are lying on imaginary axis. Poles are not in left hand side of the plane, right? So final value theorem is not applicable. Theorem not applicable. Okay, this is the first thing you can see. Or what you can see, what is f of s? That is a upon s square plus a square. Tell me what will be f of t? You should know it. What will be f of t? Sin 80 ut, right? So this is what? A periodic signal, right? The waveform will be like this, periodic, keeps on going, periodic signal, keeps on going like this, right? This will be your f of t. So because of this periodic signal, the signal is periodic, that's why you can't apply final value theorem here. Okay. Okay, so shall we take another example where you can apply the final value theorem actually? So I guess I can take an example. What example shall I take? Let me think. So this is the example. Okay, so we can write f of s as s upon s plus 3 s plus 4. If you make the pole zero diagram, one pole will be at 0, this is sigma, this is j omega. One pole will be at 0, one will be at minus 3, one will be at minus 4. So final value theorem is applicable. Value theorem applicable, right? So f of infinity would be limit s tends to 0 s into f of s. So limit s tends to 0 s into f of s and s will get cancelled. So s square plus 6 upon s plus 3 into s plus 4. So 0, if you put s equals to 0 here, this will be 6, right? And if you put s equals to 0 here, this will be 4 into 3, that will be 12. So 6 by 12, that means it would be 1 by 2. So final value will be 1 by 2. Okay, so this is your final answer. So this is the initial value theorem and final value theorem. So that's it, I guess. Okay, so for gate aspirant, knowing this much is more than enough. Okay, for placement guys, there are few more concepts left. Okay, what are those concepts? Like the current thing that I told you, Then you need to know basics of control system as well, like what is Bode plot, what is transfer function. Like transfer function we have already studied. This is only a transfer function. This is what we call a transfer function. Output by input is transfer function only. So these things you also need to know. Then you will draw the Bode plot also. Then you will tell the pole 0 as well. Gate aspirant will learn all this in control system. For network analysis, this is enough for them. All this will be studied in control system for gate aspirant. Like gate aspirant will study control system very deeply. They will study root locus and Nyquist criteria, RH criteria, all these things. But placement guys will not have to study all these things. So whatever from control system that is necessary for placement aspirant, placement guys, so that I will tell in some other video, and then I will put more of network analysis. So for gate guys, here the RC circuit part gets end. Now we will solve question, then we will move on to RL circuits. So for placements as well, now we will solve the question and move on to RL circuit, but we will again come back to RC circuit in the last. Okay, when I give the concept of control systems, then after that we will be studying RC circuit again. Okay, because few more concepts are left that you will understand only after studying the basics of control system. So first we will study that basics of control system, that we will move on to again that RC circuit part. Okay, so I hope you are enjoying the lectures. This lecture was a bit tough, like this in the initial analysis was a bit tough, especially this one. So I hope you have understood the concept. Okay, I tried to teach the concept in as deep manner as I could. Okay, and then we saw this simple RC circuit. This was very easy. Then we saw this initial value and final value theorem. So I hope you are enjoying the lecture. I hope you have understood a lot of concept, a lot of new things here. Okay, this question is left, but I guess I don't need to teach this. I will leave up to you. Okay, in some doubt class or anything I can discuss this problem, but I'm leaving up to you. Try solving it. Not an easy problem, like not a straightforward problem. Like if I tell you the final answer, it will be very easy, but I want you to think about it. What will be your V0 value? What will be your VC value? Okay, I want you all to think about all these circuits, and then we can discuss this in doubt class. Okay, or in any class. But for as of now, I'm not going to discuss the problem. I am leaving up to you. You need to draw V0 waveform, IC2 waveform, IC1 waveform, and IR waveform. First, try thinking about the current. If you think about the current, you will be able to draw the VC, V0, IC, IR, and IC2 waveforms. Okay. So let's meet in the next class. There we will be discussing an assignment. Okay. Thank you.